안녕하세요 여러분, 헬입니다. So in this video, we're going to study binomial expansion. So before we start, always let's try to see what binomial expansion is. So bi, it means two, right? And nomial, where have we heard the word nomial? Polynomial, right? So what this means is that, so this is something like, so it's related to polynomial. So instead of poly, we have two. So two nomial, that means we have two terms to power n. And this is what we are trying to expand it out. Okay, so let's, so of course we can't really expand this out right now. So let's try to simplify the case. So let's say we have a plus b to 0. Then what do we have? We have 1, right? A, unless, so here a and b are not 0. So and a plus b to 1, that's just a plus b, right? A plus b squared, that's a squared plus ab plus ba plus a squared, b squared. So you have a squared plus 2ab plus b squared. And a plus b cubed, what we have is that we have a cubed plus a squared b, 3a squared b, 3ab squared, and then we have b cubed. And then we will have a similar thing for to the 4 and to the 5 and so on. So something like this and so on. And we're going to see what we will have when the power is n. So before we directly see that, we can see that there are some coefficients, right? Some of these coefficients. And if you have heard of Pascal's triangle, we can see that the numbers in the Pascal, so the numbers on each level of Pascal's triangle refer to the power here. So these coefficients, we can use the Pascal's triangle to use it. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, right? So 1, 1, 1, that means 1, 1, right? 1, 2, 1, 1, 2, 1, 1, 3, 3, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 4, 6, 4, 1, right? But the problem is, for example, when we have to expand out like x plus b to 15 or x plus b to n, then we can't really, Pascal's triangle will not be that useful to do this, right? So in order to expand this out for SL students, you have to know some things called the binomial coefficient. And in order to learn this, you need two new mathematical symbols. So this is not the exclamation mark, it's called the factorial in mathematics. And so if we have n factorial, that means we are basically multiplying n minus 1, n minus 2, all the way to 1. Okay? So for this case, n must be a positive integer. And we have a binomial coefficient, so this is called the binomial coefficient, and this is defined as n factorial over r factorial, n minus r factorial. And if you're in HO students, I mean for those HO students, you should probably know these two from counting principle. So SL, you don't do counting principle, that's why you don't need it. But what this means, so we write this as NCR, and it's also called a combination. So this means that out of n objects, we're looking for the number of outcomes where we have to select R objects, and these objects are indistinguishable. So for example, let's say you have a bag of like 10 candies, right? And let's say all the candies are identical, then what we are basically doing is that we are trying, oh no, so let's say there are like yes, all different candies, so 10 different candies in a bag, and let's say how many combinations or how many outcomes are there to select 4 candies. Then what we can do is that we can just simply write 10CR, or 10 factorial over R factorial 10 minus R factorial. So that's what it means, okay? So it's combination. Then what about this? It's just basically lining up the object. So for example, let's say you have 1, 2, 3, 4, 5 numbers. So 1, 2, 3, 4, 5. So 5 numbers. And let's say you want to form a 5-digit integer. So it has to be positive integer for this case. Then how many numbers can we form? We can form 5 factorial number of numbers. 5, 4, 3, 2, 1, which is 120. Okay, so these two have a lot of meanings in counting principles, and using this idea, I'm going to explain how we can derive the binomial theorem. Binomial theorem. You don't need to know the proof, but I think it's going to be very useful if you understand how we can derive binomial theorem, because it has a lot of meanings. So we go for the binomial theorem. So now binomial theorem is basically expanding this out. So alright, so I should have written down in more detail. Alright, so this is binomial expansion, and if we binomial theorem or expansion, and if we write this a bit more nicely, we will have this. Alright, so these NC0, NC1, NC2, NCn-1, and NCn, they're all called the binomial coefficients. And let's try to use the definition of binomial coefficient again. So I said that the binomial coefficient, this NCR, is simply the looking for the number of combinations where you have n objects and when you have to select r objects. So let's investigate this first term here. So NC0, A to n, and B to 0. So first, how many A plus B do we have? We have n number of A plus B all multiplied, right? So A plus B, and all the way to A plus B, and we have n objects, right? Then what we can think is that there exists total n number of A and B altogether. So what you're trying to do here is that you're basically trying to select n number of n A's. So you're selecting n number of A. Okay? And can we select more? No, because we have until n, right? So we cannot pick until like n plus 1. We cannot have n plus 1, right? Because we only have n objects. So out of n objects, we select n A's. Okay? That means how many B's can we select? No, right? Because we have already selected all the objects. So we have A to n and B to 0. And this coefficient means out of n objects. So we can write it as NCn. Out of n object, we select n number of a, or we can also say that out of n object, there we select 0 b. Okay, and the reason why we can do that is because binomial coefficients are always symmetrical, right? So 1 1 4 4 6, 1 1 3 3, 1 1 2. So they're always symmetrical. That's why we can treat it as NCN as well if you want to choose A as a subject, or we can write B as 0 here when I choose B as a subject. Okay, so this is how we can find the first term, and we move on to the second term. So what this means is that, again, we have n objects, and we select n minus 1 A's. Then how many B can we select? 1, right? Because we cannot go beyond n. We only have n number of objects total. So we have n minus 1A and 1B. That's why summing up the powers of these two, we always have n. See, n minus 2 plus 2, that's also n. 1 plus n minus 1, that's also n. So it's always n. And what about this binomial coefficient? NC1, that means out of n objects, we look for the combination of selecting one object. So that means, so I made B as a subject, that's why out of n objects, I looked for the combination of selecting one B. So we have NC1, which means n number of A n minus 1B, okay? And it's the same for the other thing. And I'll explain a bit more about what it means by n number of A n minus 1B. So let's simplify the case a bit. So let's look for A plus B cubed. So here I directly expand it out, but I'll expand it out a bit slowly. So do not add up the intermediate terms, okay? So that's A squared plus AB plus BA plus B squared, and we multiply by A plus B. So that means we have A cubed plus A squared B, right? And plus A squared B, right? And plus AB squared plus BA squared plus B squared A plus B cubed, right? How many terms do we have? We have 8 terms. Why? Because 2 to 3, okay? Alright, so that means how many A cubed do we have? 1, right? And how many A squared B do we have? 3. That's what it means, okay? So this one, again, if we use this idea, so we have total 3 objects, right? So, I mean, we can choose 3 objects total. So what do we have if we choose 3 A's? That means that's in fact 3 C3. So out of 3 objects, we select 3A, and then that means we have 3 A's and we don't have any B, right? And plus, the second case is where we choose 2A. So out of 3 objects, we choose 2A. That means we have A squared, right? So because we chose 2A, right? And we will have 1B. The next one will be out of 3 objects. We select 1A. So that means we have 1A. And we will have 2B. And lastly, out of 3 objects, we select no A, 0A. That means we will have 3B, right? And what's 3C2? So 3C2 is 3 factorial over 2 factorial, 3 minus 2 factorial by definition here. And it will be 3. So that makes sense, right? Because we have 3 number of A squared B, right? And it's the same for this as well. We have 3 number of AB squared. Oh wait, am I missing? I'm missing one term. Sorry. A cubed, A squared B, A squared B, AB squared, BA squared, B squared A, B squared A again. Oops, sorry. So B squared A plus B cubed. Right. So we will have 3 terms for this too. Okay. So that's how we can derive this equation. Oh, so A to 0 is just 1, so let's just write it like that. One thing, so when you have a 0 factorial, it's not undefined, it's 1. And for this, I'll tell you to memorize this. So just memorize it by definition, okay? So this is the binomial theorem. So what you have to remember is this, okay? So I'll write it a bit better again. So when you have this, then you'll have a to n, and then nc1, an minus 1, b, plus nc2, an minus 2, b squared, plus all the way until ncn minus 1, a1, b n minus 1, plus ncn, a to 0, b to n. Okay, so that's the binomial expansion. And what can we do with binomial expansion? So let's try some examples. And in fact, so even for example questions for binomial expansion, if you just started learning binomial expansion, this can be a bit difficult. So if you want to try very simple questions, please try those questions in the textbook, okay? But I'll try easy examples with you too. But I'm also gonna try some difficult ones as well. So show that this equation holds. Alright, so for our first question, we already have a proof question. So some may find it very difficult. Okay, it is actually not easy to solve, but the reason why I'm putting this as the first example is because this is one of the main application of binomial theorem. So if those students who have learned some of the sets in their secondary math, and if you have heard of something called the subset, so if you have a set, then the number of subset is, you can find the number of subsets using this formula where n is the number of elements of a set. So for example, if you have 1, 2, 3 in a set, then the number of subset of this set would be 2 to 3, which is 8. But at that moment, you guys couldn't learn the derivation because this is, so for the derivation you need binomial expansion, and this is the point where you can derive the formula. So what do they mean? That means, so the first one means out of n objects, we select 0 object, which means the empty set for this particular example. And nc1, that means out of n objects, we select 1. So we are looking for a subset that contains one element only. And for this one, out of n objects, we select 2 objects. So for this one, for this example, out of 3 objects, we're looking for the number of subsets of 2 elements. And nc3 will be out of n objects, we select 3 objects, right? And if we apply in this case, we are looking for a subset where it has 3 elements. So that's why for this one, we have 3c0, 3c1, 3c2, and 3c3. And then using the formula that we have already from the set number of subsets, we have 2 to 3. And in fact, it is 2 to 3 because that's 1, that's 3, that's 3, that's 1. So it's 8, right? And it's also the same for the binomial coefficient of a plus b cubed, right? Anyway, so that was a bit long story, but yeah, so let's see how we can prove this. So let's try to make these, the left-hand side, into the form that we know. So this is what we have. But normally, we don't just have binomial coefficients, right? We have some unknown variables as well. So let's recall the binomial expansion of a plus bn. So that means we have nc, so I'll use nc0, nc0, a to n, b to 0, nc1, a to n minus 1, b to 1, nc2, a to n minus 2, b squared, and we add all the way until ncn, a to 0, b to n. So we have all these binomial coefficients, right? But the difference between this equation and this equation is that we have more variables here, while this one doesn't have any variable. Then how can we eliminate the variable without affecting the equation here? So what we can try is that we can let a and b be 1, right? Because 1 to n is still 1, so 1. 1 to n minus 1 is also 1. 1 times 1 is 1. 1 times 1, 1 times 1, right? So when a equals to 1 and b equals to 1, that means 1 plus 1 to n equals to nc0, nc1, nc2, and all the way until ncn. And this is why it's 2 to n. Okay, so that's it. Well, not that hard, but like every proof questions, if you know how to do it, it's not that hard. But the point where the starting point is always the hardest part. But yeah, so that's it. And for the second example, I'll try a more realistic example in IB binomial. Okay, so let's say we want to find the coefficient of x cubed for 3x minus 2 to 7. Alright, so the questions in your exam or test, you will rarely be asked to expand the entire thing out unless the power is like a bit low. So like 3 to 4, then it's easy to expand out. But when we have something like to the 7, well, you will still have to expand this if you're in HL, because you will do a lot of these expansions in complex numbers. So please study binomial well if you want to do complex numbers soon. Alright, anyway, so yeah, so most of the questions you will just be asked to find a particular term. And how do we find the particular term? So we see that we only learned for the entire expansion, right? Then what we can do is that for finding the general term, so we use the idea. So that this means, so if B is the subject, out of n object, we select 2b. That's why we have b squared, right? So general term means something like, let's say, x to r. So with a certain power. B to r, let's say. B to r. Then what we will have is that out of n object, we select r number of b. Sorry, I'll use red pen, it's a bit hard to see. So out of n object, we select rb. Then in that case, there will be n minus ra and b, r number of b, right? So we can use this. So what that means is that the general term for this would be 7cr, 3x to r, and negative 2 to 7 minus r. Because what this means is that, again, out of 7 objects of 3x and negative 2, we select r number of 3x because we need x, right? So we are selecting r number of 3x. Then the rest will be negative 2, right? And how many, what I mean by rest is a 7 minus r, because if we chose r number of objects already, then we can only choose 7 minus r objects, right? So using this idea, what we can do is that we can just write down the equation again, like this. And for this case, what should r be? R should be 3, right? Because we want x cubed. So that means 7c3, 3x to cube, negative 2 to 4. So this binomial coefficient, this is how you can calculate it. So this should be the coefficient, and I will not calculate this. I'm too lazy to use the calculator. So that's the example of binomial theorem. And for SL students, and also possibly for IGCSE, and definitely for HO students, you will have some simple product with binomial term. So what that means is that something like another thing multiplied to this, the binomial expansion. And you will be asked to find like the coefficient of a specific term. So let's try an example. Let's say we have something like this, and we want to find the constant term. Okay, there are multiple ways to describe the constant term. So the questions may directly say constant term, but it may also ask you to find the term independent to x. That also means the constant term, because independent of x means there's no x, right? So it must be a constant. So yeah, how do we find the term? So we apply what we know. And this one, we don't have any power, and it's not in a binomial form, right? So this is something called a trinomial, because you have 3 terms. So let's try to look at this first. X plus 1 over x to 10. So if we want to find a specific term, we can try to use the general term, finding the general term out. And rather than just memorizing the term, that formula, you can just use the idea of binomial. So out of 10 objects, we select our number of objects, where the object is either x or 1 over x. So we want to find, we want to select our number of x. But for this one, both of them include x, right? Then which one should we select doesn't really matter, okay? Because you can just solve for r for a given condition, and that's just simple algebra. So don't worry. You can let 1 over x be, you can make 1 over x to r. That's also fine. But yeah, for this one, so make this into an exponential form, because we will handle with exponential a lot. So x to negative 1, and then how many objects are we selecting? 10 minus r, right? So this is how the general term would look like. And if we since we have the same base, why don't we group the power together as well? So that one will have x to 2r minus 10. Okay? So from here, what we will have is that we will have the terms in this form. And you can see that we have another equation multiplied. So that means from the term we find from here, we will have to multiply with one of these terms, right? Not both, but like one specifically, or the other one, like that. Not two at the same time. What I mean is that. Okay, so there are 3 candidates we can form. One of the term here, which is this, multiplied by x squared, right? Or one of the term here and multiplied by x. And lastly, one of the term here multiplied by 1. And for each case we find the appropriate r. And for this one, we have another x squared. That means x to 2r minus 8, right? And for this one, we will have 10cr x to 2r minus 9, and this one will be the same. Right, then we want to find the term, constant term, and what does that mean? It means we're looking for the power of 0 of x, right? Because that's how we can have the constant term or the term independent to x. So this one r should be 4, and this one r should be 9 over 2, and this one r should be 5. And does this make sense? It doesn't make sense. Why? Because think. So that means 4.5, right? Then 10C 4.5. Out of 10 objects, we select 4.5 objects. Can we divide an object? No, right? There's no such thing as 0.5 objects. So that's why we don't consider this case. So we reject for this case. So we just look for these two. So the coefficient from here, the constant term from here will be 10C4, and the constant term from here should be 10C5. And these two are the separate constant terms, right? From this expansion, then we add them together, right? Therefore, the constant term would be 10C4 plus 10C5, and alright, I don't really calculate these values, but I think most of you will not have enough experience from in calculating these binomial coefficients unless you're in HO, so I'll just quickly try with you. So 10 factorial over 6 factorial, don't write this down as like 10 times 9 times 8 like that, okay? You see that we can already cancel with 6 factorial, so this will only have 10, 9, 8, 7 multiplied, right? The rest, 6, 5, 4, 3, 2, will be cancelled with 6 factorial in the denominator. So for this one, we only have 10, 9, 8, 7, and we divide by 4.432, 1, okay? Plus, again, it's the same for this. So we have the 5 factorial as the denominator. So 10, 9, 8, 7, 6, and after 5, they all disappear. And we still have one more 5 factorial. So this is what we will have. And again, don't multiply this out directly. You can cancel as many things you can. Cancel as many things as you can before you calculate the product. So we can see that. I should have left 10, but it's too late, I guess. So we will have 462 as a constant term. Okay, so this is how we can do it. Last thing for SL is finding the exact value of a how should I say, like a very complicated rational number. So, well, I said very complicated rational number, but I don't like having really complicated numbers, so I'll just simplify a case. So let's say we want to find the exact value. Exact value of this. Then, well, to be honest, you can just write it as 1.01 and just multiply 1.01 4 times. That one should be the easiest, to be honest, although it takes more time. It takes some time. But we can also apply binomial expansion to do this, because that is simply 1 plus 0.01 to the 4, right? So that means 1 to the 4 plus 4 times 1 to 3 times 0.01 plus 6 times 1 squared, 0.01 squared, plus 4 times 1 times 0.01 cubed plus 0.01 to the 4. And that's 1, that's 0.04 plus and we have 6, so we have this, and 0.000004. So this is what we will have. So we have 1.04060401. This is what you should get for the exact value. Okay, so that's it for SL binomial. So quite easy, right? I mean, quite simple. Alright, so if you're in HL, you have one more thing. So for SL, you're done with this, and IGCSE, you're done with this. But for IGCSE, you also have to consider the case where n is rational or integer, so like negative number or like rational numbers. So for that case, since we don't need that for IB, so unless you take IB HL calculus option, and you will have that a bit in power series. But yeah, so it's not in the IB core syllabus. So I'll talk about that in the later video. So yeah, SL and IGCSE students, you're done for it now. And what I'm going to do is that I'm going to do a further two more examples for HL. So we have seen the simple product, right? Then what about hard products? Harder products. So the previous case was without power, or should be a very simple power like 2, so that you can just expand it out. But what if you have like a 2 binomials multiplied by each other? So like something like this. And you want to find the coefficient of x cubed. Don't panic. So it's just use what you know. So for this one, we know that the general term would be 4cr, 2x to r, and 1 to 4 minus r, but 1 with any power is still 1, so forget about it. And from this one, what we will have is that 5cr, x to r, and negative 3, 5 minus r, right? And you're multiplying these two together, right? Then for any term you will have, you multiply with the other term here. So that means the general term of the products would be the product of these two, but be careful because we used r here, and there's no guarantee that this binomial will have the same r. So let's use some other variable, something like k. Okay, then I should have used the binomial coefficient, but it's the same idea. So you guys all know the combination, right? Because you're in HO, so I'll just use C. So this is what you will have. Then let's move all the constant by constant and x by x. So for the constant, we will have 4cr, and we will have 2 to r, right? And we will have 5ck, and we will have negative 3 to 5 minus k. And for x term, we will have x to r and x to k. And since we have the same base, that means so this one we can write it as x to r plus k. Okay? Alright, then what should this be? R plus k must be 3 because we are looking for the coefficient of x cubed. But we have two variables with one equation, right? Then we cannot find the unique solution. Well, don't worry, you will not supposed to find the unique solution. You will have multiple values, and note that r and k are both natural numbers, right? So we don't have, not natural number, it can be 0 as well, so 0 or natural number. So that means for this, if we consider a form like this, then we can have 0, 3, 1, 2, 2, 1, and 3, 0, right? And can there be anything else? No, right? So we evaluate the constant for each case. So for 0 and 3, that means 4c0, 2 to 0, 5c3, negative 3 to negative 3 squared, right? Then what about 1 and 2? That should be 4c1, 2 to 1, 5c2, negative 3 cubed. And for 2 to 1, we have 4c2, 2 squared, 5c1, negative 3 to the 4. And lastly, 3, 0, that means 4c3, 2 to 3, 5c0, and negative 3 to 5. Calculate the values and add them up. And that's it, okay? I will not calculate this, okay? You can use your calculator to solve this. So that's one of the example. And one more example you will have is an example with trinomial. So I just told you that trinomial is something that we have, something looks like binomial theorem, but it looks like, binomial, but it has 3 terms. Like this, and you want to find the coefficient of x cubed. Again, don't panic, just use what you know. So you know binomial expansion, right? Then why don't we make this in the form of binomial expansion? How can we do it? Well, we can consider x squared plus 1 over x as one term. Like this, right? Then the general term would be 6ck x squared plus 1 over x to k, and 1 to 6 minus k, but that's still 1, so let's not consider it. And this one is now a binomial, right? So we can form KCR, right? X, we select R number of x squared, and that means we will select k minus R number of 1 over x, right? So again, we can just make rewrite this into constant by constant and variable by variable, but there are not many constants to do, so we just need to consider these two and change everything into exponential form. Then you will have this. So if you rewrite this a bit, you will have x to 3r minus k. And we want to find the coefficient when x equals to 3. I mean the power of x equals to 3. So 3r minus k equals to 3. Then again, we have two unknown variables with one equation, but don't worry, we have a restriction for r and k, right? R and k can only either be 0 or natural number. And one more condition. Can k be smaller than r? No, right? So k must be greater than r. In other words, r must be smaller than k. So let's find the values that this equation can hold. So doing the similar thing that we just did. So let's say it's r to k. Then we have 1, 0, right? Or 2, 3, or 3 to 6. And using this condition, can this be the option? No, right? Because that means 0c1, right? And it doesn't make sense, so we only consider for these two cases. So when we look for this case, that means 6c3, 3c2, and then x to 3. So that's the coefficient. And we also have another term with 3 and 6, so 6c6 and 6c3. So this one is simpler. So that's what, 15 times 3, and that's 15. It's 20, right? 20, yeah. 20 times 3. Yeah, 20 times 3, and this is 20. So the answer will be 80. Okay, so we have seen all the cases for binomial expansion for HO2. Okay, so again, you will also have the approximation, like what we did for SL. So that's it for IB binomial. So see you guys in the next video. Bye.